Welcome back to the lab. On the bench we have yet another 576. So this particular curve tracer, this is actually the first one I got. You can tell by the ding in here in the frame, but we'll see if we can do something about that because I now have a parts unit. This particular curve tracer is older than the one I restored in a previous video by a substantial amount. I can tell by the parts that are in it. This one also has the older style tube. It doesn't have the indicator at the bottom left. So this has the -00 tube, where the other one has the -01 tube. So nothing really too much there, just different. Because this had a different tube, I decided I would take a look at it and see about getting it repaired, getting it fixed. The astute among you guys will probably notice some of the knobs are not for this unit. They blend in very well, but there's two knobs that are not original on here. They came off of something else because this thing had a pretty rough life before I got it. This one was my original one that had the bad transformer in it, so that's actually, this unit right here is what actually this transformer came out of. So this now does have the silicone transformer because the other unit I got happened to have the better transformer, so I was able to swap that out. This also happens to have a good tube as well. It's in very good shape given that it's an older unit and that's hard to find. So all in all, this is a good unit, good restoration candidate. We'll go through this thing. I'm going to start on this one with the same work I did on the previous one with the power supply. So if you guys are curious as to what I did to the power supply, take a look at the previous video. I'll have a link in the description. Not going to go through too much of that here because that's stuff we've already covered. But so I will get to it, getting this thing recapped and getting it all set. And then I had some questions actually about a calibration on one of these and how to do a calibration on one of these. So we'll go through a calibration on these. I do have the calibration fixture, so I'll be using that for this calibration. For those that don't know, there is a alternate calibration method. It's a lot similar as to the 177. How to do the calibration on that. You use standards resistors and a few other things. Some of the resistors, which I have, their tolerances are incredibly tight. The service manual calls for 0.25% tolerance, and you need some pretty beefy resistors. I mean, this guy's 1 ohm at 10 watts. So you got to get a 1 ohm resistor within 0.25% tolerance to have the curve tracer be in tolerance. So that's actually a pretty tall order. The easiest way that I found to do that is don't try to find 0.25% resistors, because finding a 10 watt 0.25% resistor I wasn't able to find one. The way I ended up doing it was I got a set of 10 watt 1 ohm resistors and just did a ohms measurement on them and just hand graded them. I actually did come up with 2 out of the 10 that were in tolerance. So these are 1% resistors, so I was in the ballpark. But I was able to get 2 that were within 0.25% to 1 ohm, so I can use them as standards resistors for testing. So these are, we'll use these probably to verify the current ranges, since I'll be calibrating it with the calibration fixture. To measure those low ohms values, you will want a set of Kelvin clips to do the 4-wire measurement, because when you're measuring, when you're trying to get to 0.25% tolerance at 1 ohm, the resistance of the meter leads can throw that off significantly. So you do want the 4-wire measurement method when you're hand grading those resistors. This is just a set of 4-wire clips. Makes taking the measurements really easy. But this is how I did it. I used the 6500 to get them in the ballpark. The 6500 has a I believe it has a 100 milliohm full scale. It does very well reading very small resistances. So that's what I used for that one. So got that all good and everything was all set. So I'll crack this thing open. I'll get in there. I'll show you a before and an after. Not that you'll be able to see much because of where the capacitors are, but if I remember correctly from the last time I was in here, there's some additional caps that I'll swap out on the power board that just deserve to be changed just due to age. This unit does work. Everything's functional on it, so I could plug it in and turn it on and it'll fire up. I had it fired up probably about a month ago, so it is functioning, but I want to get it squared for the long haul, so we will get that taken care of, and then we'll get into a calibration on a 576. And it looks like a city inside. So you could tell this is one of the older units, given the gold tracing on the gold traces on the circuit boards, the way the pots look. This one actually still has the original roll of solder from Tektronix in it, so this one's in very good shape. There's some more capacitors in the power supply that I want to swap out. They're just some of the older ones. Do some preventative maintenance, get this thing all set up and ready to go, and then we'll be able to put this guy back in service for a long haul. So what I'm going to do is I'm going to get these regulators out, because the main thing that I want to attack is the bulk filters underneath these two boards. So I'll get those boards popped out, I'll start attacking those, and then we will be ready to go. Yeah, I think that's it on this one so far. Then we'll get into calibrating it and see if we can't actually get this thing back into cal. So when I get these boards out and these caps swapped out, I will be back. I got about 8 hours worth of work to do. For you guys, it'll be about 30 seconds. So one thing I was made aware of from the last video I did to today, if you remove the handle, which is 1, 2, 3 screws, 2 on the front and 2 on the back, you can get access to the bulk filter caps without taking the tube out. So we'll see how that goes. It's going to be tight. There's not a lot of room in there, but I think I'll be able to do it. We'll see what happens. If I do end up having to take the tube out, I will let you guys know, but we'll try this one without the tube coming out. We'll see how it goes. Well, I have to say that was most unpleasant. I got the caps replaced. As you can see, all the adapter boards are in. These last 3, it is possible to do them with the tube in. I did not take the tube out, so it's doable. I have pretty large hands, and my fingers could barely reach to get these last couple of bolts tight. Here, those last couple of bolts tight. So your mileage may vary. If you have a filter that's in here and you got to get this deep into it, it's a toss-up. I may still pull the tube and set the tube aside and do it. It is possible to do it by removing the handle, but those last 3 are a struggle. If you only want to do these top 4, they're not too bad, but you got to work down from the top, because you got to have the smaller capacitors in before you can get the bigger ones out. So the way you got to do it is you got to start at the top, work your way down with the smaller caps. They get significantly smaller as they get newer. But, so yeah, there we go. So I get to move up 1 layer. This is all done. I'm going to triple check this wiring so we don't blow a cap. I did check all the polarities of the caps. They're all right. This is my next board. These Sprague caps have to go. So I got to get them out of there, get some replacements for those. And then we will see what we can do for that. And then the next stop's going to be this top board. Get this top regulator board done. And then when that board's finished with caps in that line right there, we'll finally be able to turn it on and see if I didn't break it. So we'll go from there. But that's where we're at. About 2 days worth of work. So still about... To do these filters, it's about 8 hours. So it's not a short process, but this should be the last time, at least in my lifetime, this unit gets it done. The old caps were 85 degrees C, so they have a voltage bump. If not an exact capacitance, a little bit higher voltage, and everything new is 105 degrees C. So they should run for quite some time without having to be changed out again. So let me see what I got to change these. I may have to order something for the sprogs, but we will go from there. I'll bring you back when I have something interesting to show you. Okay, here's the regulator board with all the new poly capacitors installed. Everything is good there. I've got this, the low voltage. This is the rectifier board, sorry, the rectifier board. This is the regulator board. I have the regulator board all put all the caps in. I'm going to get that bolted back up and we'll fire it up and see what happens. Alright, here's the low voltage regulator board put in. All the new capacitors are installed. Everything's good. I went through the unit and looked for any more that I could find. The only other two that I could find were right here, so they got replaced as well. Everything else looks to be ceramic and poly, so everything else looks good. So give me a second and I'll turn it on. Okay, I've got it hooked up to the unregulated supply, but I'm monitoring the current draw, so moment of truth, did we wire the power supply correctly? No smoke. And we have a trace, or a defocus spot. I have the focus control all the way defocus so we don't burn the tube, but we have high voltage. Everything's running. It's actually dropped. It was drawing 59 watts before the rebuild. It's now drawing 49 in the same configuration, so we dropped 10 watts of standby power, so definitely we're leaking something through the power supply, so that's been rectified, so that's good. I just gotta put the side panels on and let this cook for a while, make sure the power supply doesn't have any problems. Once I do that, we will give this thing a calibration. Okay, as you can see, I have the power supply hooked up to life support. The important meters is this is warming up for the high voltage, so this one's not hooked up at the moment. This is on the negative 75 volt rail, so that's the critical rail, so I have the Keithley watching that. This is all the auxiliary rails of the power supply, so when I turn it on, it should give us an idea as to how the power supply is. We can set the 75 volt rail, and the other ones should fall in line. We have had it powered up, so not expecting any excitement. Everything was working a minute ago before I hooked all the meter leads up, so we'll go ahead and fire it up. And there we go. Okay, so it's actually not terrible. Negative 74.95. This is 100 plus 12, minus 12, plus 5, plus 25, and plus 15. So everything's within a sanity check range. So I'll get an adjustment tool, and I'll adjust negative 75 and see what the rest of them do. Okay, the negative 75 volt adjustment pot is right here. It is not taking much. I'm just bumping this control. Well, we're going to call that good right there. 75.16, bouncing between 1.6 and 1.4 with line voltage. So that's good. Tolerance on that one is plus minus 0.375 or 0.5%. So we are very good on that. Let me check the rest of the rails here real quick. I'll have to hook a scope up and check them for ripple here in a minute. There shouldn't be any because it's all brand new caps, but 100 volts. Plus 12.5. Negative 12.5. negative 75, plus 5, plus 4.5, but that's variable, so that should not be 28. V. I'll see if that's actually even on V. That may not even be on the right pin, so I'll look into that. Z, because plus 4.5, the graticule lights were off. So that is, that's the illumination lights and the graticule lights. So that's why it's high when they're shut down, because there's no current. And then plus 15, so this is on the right pin. You just need to turn the graticule lights on and it does its thing. So I will get the scope out, I'll check it for ripple. Actually, I'll shut it off, get everything disconnected, then I'll check it for ripple. We can start in on the calibration. Oh, here's the tolerances. I'll go through these real quick. Negative 12.5 plus minus 0.3 in spec. The variable should be 4 volts with readout illumination fully clockwise. It is plus 5 volts, has a tolerance of plus minus 0.25, well within spec. Plus 12.5 has a tolerance of plus minus 3.1 in spec. Plus 15 has a tolerance of 0.75, nicely in spec. Plus 100 has a tolerance at 2.5 volts. We're at 100.4, so that is within spec. And I need to hook up to the 225 volt connection. Actually, I got one more meter. We can hook that up here real quick. Give me a second. Okay, I have this meter hooked up to the 225 volt. So we should see that here in a second. 222. And I have a tolerance of plus minus 9 on that one. So 0 problems there. I'm going to let this warm up for a little bit. I may need to readjust the negative 75 because it's reading a little high now. But we'll see what happens when it warms up. Okay, I tweaked it just a little bit. This supply wants to be a little on the low side, which is fine. It's climbing a little bit, so everything's looking okay. That is a nice voltage on negative 75, so everything looks great. Meters all look happy. Everything looks good. I'm at 221. That's 225. I could be as low as 216. So, well within spec there. The next, if you do ever work on one of these, be extremely, extremely careful. The first time I worked on one of these, I almost blew up a meter. This purple wire right here on the intensity control pot, that's the negative 4,000 volt supply. So the negative 4,000 volt supply is exposed on the top of this unit. Put your hand on the top, do anything like that, you can get blasted by 4 kV. So be extremely careful around the focus and intensity pots in the back of the unit, especially when it's on and powered up. I'll show you exactly where that is here in a minute when I get the high voltage probe to check the negative 4 kV. And then we will continue with the calibration. So I'm going to shut this down, get everything unhooked, get everything set up for the negative 4,000 volt measurement, and then we'll continue on. Sorry for the shaky camera, but this is what I wanted to show you guys from the top. Here's the top of the unit. There's 4,000 volts. I'll bring this down because the camera doesn't show you much depth perception, but there's how close you could rest your hand on top of 4 kV. So be extremely careful working on these. Both of these pots have high voltage on them. That's why they have these insulated shafts on them. So that's what's going on. These are not the original couplers that come with these. These do have insulation on them though, so that's a plus. These are push button couplers from a 486. Yeah, 486. 45. Because the plastic was destroyed on this one. The unit was so old. So just a safety warning on that one. That's what the job for the repair looks like down in there. But I'm going to go back on the tripod. Hopefully I didn't make you guys motion sick. And we'll do the negative 4,000 volt measurement. And that's enough of my inability to hold a camera steady. This is the meter. I've measured this. I know on 20 volts it matches the voltage divider for the probe. The Fluke high voltage probe is up there. There's an alligator clip that just runs off the end. Just note these alligator clips, and this is silicone meter lead wire. It's not rated for 4 kV, so you could get zapped just off the insulation on this wire. So I'm nowhere near this test setup while it's running. And the unit was off when I hooked it up. I'll turn it on, take the measurement, turn it off, unhook everything, and then continue. Above 1,000 volts is when stuff starts to get jumpy. So always take precautions, especially when working with high voltages. And as you guys can see on the meter, remember this is 1,000 to 1 division. Multiply this by 1,000, gives me 3,931.6 volts. And I am allowed 160 volt tolerance. So we are within 70 volts of 4K. So that is fine and healthy. Everything is good there. So we'll turn it off. I'll unhook everything again. And then we'll continue on. Ripple is well within spec. Everything looks good. So we are good there. So time to continue. Well, of course, it's got to be good news. You turn the thing around. I checked all the power supply rails, and we were running about 5 millivolts peak to peak on, maximum of 5 millivolts peak to peak on all of them. So the capacitor, the recapping of the power supply went extremely well. Everything is working very, very well. Nicely within spec. And we're ready to go. So let me get the other piece of equipment I'm going to need, and we will start going through it. Okay, step 2 is adjusting the calibrator voltage. We are looking for, this is positive DMM on test point 510. Negative DMM, which it doesn't say in the manual, is on ground. I just have it hooked to M on the power supply board, which is where it was hooked before. On the reference, you're looking for a reference voltage of 2 volts, plus minus 0.5. So, oh no, sorry, plus minus 0.5%. So 2.01 plus minus. So we're at 2.00, well within spec. Everything's good here. Don't need to change anything. We're going to adjust the Crt controls. Actually, I need to pull the side panel off for 1 sec. And I had to move it over because for anybody who hasn't seen one of these in person, this is just a massive, massive unit. It's huge. It also weighs 90 pounds. So what we are looking for, actually that could be adjusted so you completely counterclockwise to defocus the spot. You're going to defocus the spot, you're going to have a high intensity spot on the screen for a little while. So you don't want it as a pinpoint. We are looking at the spot for general roundness because we're going to adjust the astigmatism control of the tube. Going to do the astigmatism control here real quick. So as soon as I get there we go. So what happens is when I rotate the astig control, it goes oblong and then it goes ovoid. So we want it right in the middle where it's as round as possible. So right about like that. I'm going to turn the intensity way down because I need to focus the spot. And it did. It pulled in real nice. So they want to make it go to the center, which is where we're at. And may use the variable collector to make a line 10 divisions long. And it wants to do trace rotation, but to be perfectly honest, that actually looks really good, but we'll adjust it since we're here. Yeah, that right there is just about perfect. So trace rotation's done. Okay, I need a shorting bar between the collector and the emitter. And we do that to vertical. There we go. Okay, so I'm checking the orthography of the tube. It is slightly off this way. It's actually in really good shape, and I'm being picky. But I can be picky. So it's slightly tilted that way, so I am going to adjust R685. This is in the service manual. This is all the adjustment points on the amp board. I'm doing this guy right here. So we will get him adjusted here right now. Okay, so it looks like I need to line the center, because the way that trace is moving, I need to center it at the bottom. And then center it at the top. And that looks perfect right there. So that's good. We will leave it at that. Okay, so I need to go to the zero graticule, which is over here. Need to go over to the zero graticule and check for a minimum of bowing. Which, to be honest, I'm not seeing any. So I'm gonna leave the geometry alone. I think the geometry is fine. We'll just check the 10th graticule real quick. Yeah, the geometry on this one is absolutely perfect, so I am not going to mess with it. That adjustment is kind of fiddly and it's a pain in the butt. This one's spot on, so that one I'm not going to adjust. I take it back. I'm not done yet. I have 2 more checks. So what I have to do is remove this and adjust this back to center. Give me more display. We're going to check the top. To be honest, I think trace is slightly tilted. Okay, I need to move the camera. I need to be right on this one. Okay, I had a bit of parallax problem. That's actually fine. If I look at the very ends, here and here, they're lining up at the graticule up top just fine. Check the same thing at the bottom. They're lining up at the... Actually, you guys can't even see that because of the way the tripod is, but they are lining up just fine as well, so the geometry on the tube is perfect. I don't need to mess with it. Okay, I'm just testing the graticule illumination. Off. On. Off. On. I'm going to check that. I think I may have a burned out lamp. Hang on a second. Okay, I have the lamps exposed. No, we do not have a burned out lamp, so everything looks good. The graticule illumination is working exactly as expected. Clean that pot a little bit probably, but everything looks good. Here's the readout board, and I have readout control, so that is good as well. Okay, the calibration manual tells me to torture the tube, so I'm going to torture the tube. Going to defocus the spot. so I don't burn anything. And I'm actually going to make it a line. So the tube has a continuing increase in brightness. One of the things they're checking for is when a tube is tired, it'll have a double ramp, so it'll get bright, dim out, and then get bright again. That's a tired tube. The cathode is worn out. There's an oxide layer preventing electrons from hitting the phosphor. So not much you can do. Sometimes you can rejuvenate a tube like that. I have 2 for 576s that are doing that. If anybody knows somebody who specializes in tube repair, I have 2 guns that are worn out. They need to be redone. It'd be nice to get those tubes fixed, but that is becoming a very, very niche skill set. So, but if anybody knows anybody, I've got 1 spare tube for a 576 that doesn't work. I also have a second 576 that right now is a quote parts unit. The only thing that's really wrong with it is the tube and the transformer. Same thing that goes wrong with all of them. So if I can get a tube for that one, we could bring another one back, but I don't know if we'll ever be able to do that one. Step 7 is checking the readout. Readout works. It does want me to check the 10x. It changed. It changed. So the readout is working. That's typically something that doesn't go bad in these. The bulbs burn out in here. There's a whole bunch of light bulbs in that card. The bulbs burn out, but the logic usually doesn't go bad. Alright, so we'll check readout again. So the vertical, 2 microamps. What it wants to check for is that this matches the switch. So there's 5, 10, 20, 50, 100, 0.1, 0.2, 0.5, 1, 2, 2, 1, 0.5, 0.2, 0.1, 50 nano, 20, 10 nano, 5 nano, 2 nano, 1 nano. So that works just fine. Now we'll check the horizontal side. So it wants to check this one, so that's 2, 5, 10, 20, 50, 100, 200, 50 millivolts, 100 millivolts, 200 millivolts, 500 millivolts, 1 millivolt, 2 millivolts. Or no, sorry, 1 volt, 2 volts. 5, 2, 1, 0.5, 0.2, 0.1, 0.05. So that works just fine. Now we're going to check the amplitude step. So it's going to be per steps. So yep, works just fine. Check the multiplier. Works just fine. Now it wants to check the math functions down at the bottom. So it wants per step is 2 volts, vertical 200 microamp. And this should be 100 micro. That is correct. 100 millivolts. Okay, I was off. 2M, that is correct. 50 nano. Should be 4K, that is correct. 100 nano. Should be, 500 micro. There we go. 5K, that is correct. 500 micro, 200 nano. 25K, that is correct. 500 micro. 1 micro should be 500. That is correct as well. Okay. So the readout board is working 100%. Nothing wrong there. If anything does go wrong on that board, it's kind of a bad thing. I have one that I pulled out. It's nothing but a whole bunch of light bulbs and a bunch of custom ICs. So if anything goes bad on there, you're going to be hard-pressed to find good parts. That brings us to step 8, adjusting the display amplifier balance. And I will do that here in a little bit. Okay, checking the display amplifiers. This is the first step in checking the amplifiers. You take the display offset from normal to 1x horizontal, and the spot should stay on the horizontal line, which it does. So that is perfect there and does not need adjustment. And you continue doing the adjustment until there's no movement. There's no movement of the spot when you switch between. So no movement of the spot between normal and 1. It's staying perfect. After that, you want to check 10x. And you move the horizontal to, and now we are moving, so our 650 is out of adjustment. And that is down by the second to the bottom. Relay. And that looks good. It's a little off to the left. I'm doing this to the side. The camera's straight on. There we go. Okay. Horizontal switch to 0.5. And we need to adjust our 645 for the 5's balance. It's right next to 650. These aren't taking much. Yep, that's perfect. That's good. That's not moving. Yeah, so everything is good there. Now we're going to do the vertical balance. Vertical 10x. Ooh, that's touchy. I am barely breathing on these controls. It's like the world's shortest game of Pong. That's moving ever so slightly, so I'm going to adjust vertical center, which is our 581. Perfect. So as I'm clicking you can hear it. The spot's not moving. And the display offset selector, vertical times 10, and vertical is 1 amp. There we go. Spot is centered. Spot moved. So we need to adjust 550, the one's balance. This is right next to the topmost relay on the display board. And if you have any doubt that you're adjusting the wrong potentiometer, because there's so many in one of these instruments, triple check it. You do not want to just have your tuning tool in the wrong pot and tweak one you did in the very beginning and have to start all over again. Two amp. 2's moving a little bit. So if I move this to 2, I'll adjust it just a little bit. Now it's not moving. So I want you to go all the way back to the beginning of the vertical amplifier and check it all again. So let's do that real quick. 10x. 1. 581. Again. Okay, that's not moving. Vert 10, 1 amp. That is dead center. 2. That moved a bit. So 545, we'll adjust the 2s here real quick. go. That's about as good as anyone could ask. Next up is the horizontal and vertical gain. They don't mention it, but you do need to put the display offset. Oh yeah, no, they do mention it. Set the display offset selector switch back to norm, off, polarity switch to NPN, which we've done. So what I'm going to do is I'm going to switch the polarity switch. Spot should come from this bottom corner, and it should jump up here to this top corner. Which it did. It looks like it may be out just a little bit. Yeah, it's high just a touch. I mean, it's super, super close. I am being very nitpicky now. Okay, so as you can see, the horizontal and vertical gain is now set as about perfect as I could get it. Took me a little while to do that. That adjustment was kind of fiddly. But we'll go back to AC. Spot goes to the middle. And now we're doing the horizontal and vertical magnifiers. Okay, I got the spot centered. So essentially what we're checking for is between 4.5 and 5.5, 10 divisions of display going across the display. It is a touch off, so I need to give it just a little bit more gain. Not much. It is very close. So this is one where, like I said, being sure you're on the right potentiometer. I'm fine on the calibration because I got to do the vertical next, but the horizontal magnifying gain is right next to the ornithography of the screen. Center. There we go. So I need a little adjustment. Now we have to do the same thing with the vertical since we just got the horizontal done, so we'll flip this over. Yep, it's a little off. Give it a little bit more. Need to give it just a touch more. Okay, that is perfect. You guys can't see it. The spot is right here at the bottom. Okay, it is at the very bottom of the horizontal graticule. I'm going to push Cal. We go to the top, but we're not quite at the top. But I do have to adjust R636. For horizontal. Yep, that is now set correctly. Now we do 1 volt collector. Align it with the center graticule. And we do it again. These aren't taking much adjustment, but they are needing adjustment. 0.5. Yep. 641. There we go. You guys will see what I was doing on the horizontal on the vertical because it'll be here, and now we need to do it over here. So there we go. the spot's off, because if you hit 0, it's good over here. We're off. So we need to adjust the 5's gain. That's the middle pot on this one. There we go. 0 cal. Looks good. Now we do the same thing for the 2's and the 1's. So 0.2. That actually looks pretty good. But that's off. So this is the top pot by the relay. That looks very good. Point 1, same drill. That's going to be perfect right there. 0. Yep. Okay, since we're doing the adjustment procedure, it said progress to step 20, which is the 0 crossing and step delay. So I will get that set up, and then I will be right back. Okay, so it did not give me enough vertical spacing to see the 0 cross very well. So the 0 cross adjusts the unit like this. So what it wants is, they want this not to be overlapping like that, but to be close to each other, but not quite overlapping. So right about there. It does say in the manual that the step gen may be inverted, but that's the R8 adjustment. And it wanted there's the other version. But see at 2, I can barely see anything, which is where the manual wants me to adjust it. So I'm moving these 2 bright spots right there. So I'll zoom out so you guys can see it. There we go. 0 cross. Okay, that looks like the manual. Kind of. The picture's really bad. So now it wants NPN. Steps to 3. 2x on the rate. That is off. R24. Okay. I've fought with that now for quite a bit of time, and I wanted to show you guys what I found. Right here, it says set it up as the initial control settings except as shown above. This is the only difference. Variable collector fully, amplitude 0.05 volts, number of steps 1, offset multi 10, step family as rep. So what they want is from here, all of these settings, which are in the front of the service manual, to be set, and then you adjust these four. That does not give you that wave shape. There's an error in the manual. I had an older copy of the manual. Vertical display offset needs to be step gen. So the setup procedure is wrong. You cannot do that adjustment with the way that was written in the manual. That is a correction that needs to be made. This is a copy of an older manual. I have 3 different manuals for this. This is the downloadable one from the Tech Wiki. This is the one you want to use. So I will get that set up again, and we will redo that measurement. We'll redo that adjustment real quick and continue on. Okay, there we go. So this actually is the first time in the calibration that I've actually needed the calibration fixture. The calibration fixture is hooked up. It is set to step gen and step gen loads. So everything is set here. I was way off on the adjustment. This needs to come back. Right there's where you want to adjust it. A good loop without being too stretched and without being overlapped like that. That is how it should be adjusted. The newer calibration routine, there was a lot wrong in there. You're actually supposed to have the horizontal value set to 10x. That's how you get the numbers here to line up with the different settings. So there's a lot of errors in the other calibration documents. So there we are. So I will continue with the older calibration document now, going with the calibration fixture, and we shall continue on. Okay, so setting the delay, what you want is everything lined up right here at this end. So I've got that one set. And we will move on to the 0-step level. Okay, I have everything set up for the 0-step level. When I'm holding the 0 button in, the spot should be in the center. It is. When I let it go, it should not move. It does. So we need to adjust our 224, the amplitude balance. There we go. Okay, now we set amplitude to 2 volts. Hey, it shifted the other way. Which means we need to adjust R97. Alright, so we adjust R97. Touchy control. But there we go. Okay. So this is a bounce back and forth, so you do that. And you do 0.5. And you adjust 224. And you do 2 volts. And then 97. .5. 2 volts. Now it's not moving at all. And you can tell here 2 volts. 0.5. 2. And it moved a little. Yep, we're good there. Then it wants 2 volts. Check the invert. Wow, that's way off. That is way off. 127. Invert 0. Did not need much adjustment, though. That was a super sensitive adjustment. That was pretty far off, but this is a very touchy control. It did not need much. There it goes. So invert out, invert in, invert out. Now we need to do the step amplifier gain, which is number of steps to 10. Amplitude is a volt. Step family is rep. Polarity invert is released. Function is step gen. Step generator is 0.05 microamp. I actually need to hook the oscilloscope up to the external monitor of the calibration fixture at the moment. The alternate calibration is a less precise. Well, not necessarily less precise, but it's just kind of bouncing it back and forth on itself. To test that, we'll use the cal fixture. So let me hook up the scope real quick. Actually, you can't do this with a modern oscilloscope. I forgot about that. So this is one other thing where I ran into that was kind of weird. This needs a differential calibrator. This needs a W plug-in for a 500 series scope to do step 23 in the old manual. To do to adjust the amplifier, the step amplifier gain. You actually need a 10 volt. You need to make a 10 volt offset. So you can kind of do some of it with a differential comparator on a 700 series scope. You can kind of do some of it with a 7A13, but I did run into a limitation on the 7A13. So I'm going to switch back to the newer calibration routine. Going to do it within the unit itself without the calibration fixture. So I'll get that unhooked and the test fixture plugged back in, because I don't have a 500 series scope with a W plug-in. So we'll do the best we can with what we got. Okay, so what we want is the 0 button to go to the center line, or to go to the center of the graticule, which it does. We jog it over just a touch. Oh, and on this step, you do still want the horizontal times 10 multiplier, because if it's on normal, you get all the dots as opposed to the times 10, which is what you need. So if we 0 it, we are right smack in the middle where we should be. And then we need to adjust R113 for center spot. There we go. Next is to press the aiding offset button. And we are allowed plus minus 2 divisions. We're at 0.7. Because plus minus 2 divisions would be anywhere between here and here, because they go on major divisions. So we're at 0.7 of a division, so we are good there. Which is good, but then we also adjust our 86 for center. There we go. Now we set center line to 0 and oppose. And we should be within plus minus 2 divisions. We are, but we need to adjust 85, which is the opposition offset. That is a very dirty control. And there it is. Next up is current balance. Okay, here's the test setup. So it's step gen output shorted to the base. This is a precision 0.1%, 0.01% 1K resistor. So we're ready to go. Flip this over to right. They want the 10th spot to be positioned at the 10th horizontal, which is at the bottom. Now we increase the zoom. We're there. Now I need to get an 18K resistor. I will be back when I locate an 18K resistor. Okay, I did not have a 18K resistor, so I had to make one. I'll show you guys here in a second. We're looking for no movement. The spots look good. Turn those off. And now we skip over to step 32 because we were doing the adjustments. But before we go, I did not have an 18K resistor, so I ended up making one. I did measure this with Keithley before I used it. It was 17.96, so close enough to 18. Okay, in this one, we are checking for a spot with a minimum width. This does have a bit of a tail on it, so I'm going to see if I can't make it better. I need to adjust C301, so I got to find 301. I think it's on the left side of the instrument, because this one's down near the high voltage power supply, I believe. So we're into adjusting the looping compensation on 32. Yes. C301 is in the bottom of the high voltage supply, so let me get him turned around. I already got the door off. So what we want to do, adjust for minimum there we go. Right about there. So not much to the adjustment, but it was adjusting. So that looks good. Ooh, we get to do the high voltage one now. Vert 1X 1500 200 volts collector. That could probably use some adjustment. It looks out. So that needs to adjust C339. That about right there is minimum spot size. Just checking between the two. Yeah, they look pretty uniform to me. Okay, I have to adjust C341. They specifically say use a non-conducting tool for this adjustment. This adjustment is a high voltages on this capacitor. Do not use a metal screwdriver. There's 1500 volts on this cap at the moment. Okay, I think that's how they want it adjusted. Let's see, 350 and 50. No spreading there, so that looked good. 75 and 10. It is looking for minimum vertical width. So that I think looks good. Everything looks good there. I have a little bit of spreading on the highest range, but no problems. And that concludes the calibration of the 576 without the... Really, the only time we used the calibration fixture was during the step gen, for the step gen loads. So let me push this back. I'll get the side panels back on, and then we'll just do some experiments. Here is our ever-present test Zener diode. So we have 51, right at 140. How about some very poorly matched power transistors from another curve tracer that still work? They were in the amplifier section and they were very badly matched. 40, 60, 80, 1, 20, 40, 60, 80, 2. Give them a little more power. So there's one side. And if you take a look, right about there is one of the peaks. I'll just mark that with a pointer. So we have one peak, or one step right about there. Switch to the other transistor. They're the exact same transistor, exact same series. Very poorly matched. There's our peak. The other one doesn't even get up that high with 10 steps. Let's see, what else do we have on the bench we can feed this thing? A random LED. Showing a bit of capacitance in there, but that is actually a 10 megohm resistor. 1% 10 megohm resistor. We are reading 2 microamps per division for the 10 megohm resistor. And with it being a resistor, you'd expect it to be linear. To get the sensitivity, I did have to test the resistor at 300 volts. Thanks for stopping by the lab, taking a look at this older example of a 576. Here's the carnage from the repair. All the bulk filters out of the supply, bunch of capacitors that were in there. Those paper caps, some electrolytics, all of that stuff had to go. This particular unit was a pretty extensive rebuild. Actually, there's one more part for the carnage too. The high voltage transformer on this one was bad. Had to get that one swapped out too. So this 576 is actually going to be good for the long haul. Everything was great. We also did a calibration on this one for minimal usage of the test fixture, going through the more modern document. The only time the test fixture was really needed on the modern document was for the step generator for the loads to do the zero crossing. If I can figure out exactly what the calibration fixture is doing at that point, I will make another video and let everybody know. At the moment, I have no idea what. I have to look at the circuitry of the calibration fixture and see what it's actually doing. This is the last 576 that I have to repair, because the other one's done, this one's done, so I don't have any more 576s to do. I have a couple more 577s and lots of various other projects to get done in the lab. You guys have any comments? I do read all the comments. It's actually one of the reasons this video was made. I got some comments about doing a calibration on a 576, so I figured we'd go through one. So if you guys have any other suggestions for me, please let me know. I'll see you guys in the next video.